Okay, welcome back everybody. Remember that I split this prerequisite skills worksheet into 3 parts. So I'm going to start the third part of the podcast. So I'm actually going to, and I wanted you to see me do this, I'm actually going to page down to number 14. So that's basically, we did all the word problems in the last podcast. So I'm basically going to start here, which really is a lot of the reviewing a lot of the graphing concepts that would have happened to you in the course before. So, okay, let's start off with this first problem, and I'm actually going to rewrite it over here. It says 11/5 x plus 2/5 y equals -2, and the directions say find the x and y intercepts for the equation and then graph the equation. So what I'm thinking of is I need a general recipe for whenever I'm commanded to find, x and y intercepts of an equation. So hopefully you're thinking, well, whenever you got to find x and y intercepts, you're going to make this little mini table, right? With zeros. And what does that mean? Well, let's go ahead and store 0 in for x, and we'll produce a y-intercept. So if you think about that, if you store 0 in for x, then 11/5 times 0 is 0, right? And if you need to write that out on the side, 11/5 times 0 is 0, so you'd have 2/5 y equals -2, and then multiply both sides of the equation by 5, let's say, to undo that 5, and then you'd have 2y equals -10, right? So I kind of ran out of space there, but you'd multiply both sides of the equation by 5, and you'd quickly arrive at y equals -5, okay? So now I know basically, and I'm going to do this in another color, I know that if I store 0 in place of x, right here, and and then think about that, either physically or mentally, I'll get out -5 for y. Let's try again. Now let's take 0 and store it in for y, and think about what we get. Now I tend to do a lot of this mentally, but you can write it out. So like 11/5 x plus 2/5 times 0, which is just going to zero out, right, equals -2. So if you keep solving for that, 11/5 x equals -2. I'm just going to scoot that over. 11/5 x equals -2 times both sides of the equation by 5 to undo that, dividing by 5. So you'd arrive at 11x equals -10. So what does that mean? That means that x equals -10/11ths. Okay? So in terms of finding and plotting the x and y intercepts, you can certainly do that. So let me zoom in on this graph. Okay, so 0, -5, where does that live? That lives, oops, let me grab that right about here. 0, negative, my pen's being fussy, 0, -5. And -10/11ths, well, that's awfully close to -1, right? So I'm just going to put a dot right here at -1, okay, comma 0. Awfully close to -1, not quite. And then just go ahead and connect the dots. So it's really those key points that I'm looking for, the 0, -5, which would represent this point right here, and the -10/11ths, comma 0, which would represent that point right there. Okay? Hope that helps. Just keep that general strategy where if you're trying to find, x and y intercepts, you can make a little mini table where you're storing 0 in for x and y, respectively. Okay? I suppose now is a good time to introduce you to another great tool. If it's midnight and you're doing your math homework and you have nobody to help you, go to wolframalpha.com or get the app on your phone. So here, I'm on wolframalpha.com, and I'm literally going to type in that same problem that we just did. I'm going to write find the x and y intercepts of, and this is such a great device because it really helps you if you're in a jam, if you're stuck. Be careful how you type it in. So 11/5 x, so that same equation that we did a moment ago, plus, but notice that when I type in my fractions, I put it in parentheses, plus 2/5 y, oops, that should be a parenthesis, 2/5 y equals -2. So I'm literally typing in that equation that we had, the same command. I hit enter, and it's thinking, and poof, it produces the answer for us. And if you have the paid version of it, like on your phone or something, it'll probably even show you the steps. So it's claiming indeed that the x-intercept is at, -10/11, 0, and that the y-intercept is indeed at 0, -5. So it's verifying what we knew to be true. Okay, nice to see. And it even gives you I think it even gives you the visual interpretation. Let me see here. If I page down, yepers, there it is. So if we zoom in, you can see the same thing that we sketched by hand. So a moment ago, so you can see the y-intercept down there at 0, -5, and you can see the x-intercept here at like -0.9. All right, hope that helps. Let's try the next one. Okay, in this next problem, it says graph the equation in the rectangular coordinate system. So I always, try to put my eye on little clues or little things that really trigger me to know what I'm doing. So for example, it says 4 minus x equals 2 and wants me to graph the equation. So the first thing that comes to mind is, hey, let me isolate x. Right, then I'd have -x equals, 2 minus 4, which means -x equals -2, which means x equals 2. But aha, I'm sure you remember from prior semesters that if you have x equals an arbitrary constant, you have yourself a, so I'm going to write here, aha. That should be an aha moment. Okay? X equals an arbitrary constant is a what? It's a vertical line. So you say, oh, I remember that that's just going to be a vertical line running through 2. Okay? On the x-axis. Now, if you didn't remember that, there's only one other thing you could do. Well, you could use Wolfram alpha, which that's just a crutch that I showed you a moment ago, but you could think about it linguistically. X is 2. This means that x is 2, despite what y is. So it doesn't matter what y is, x is always 2. And if you go to plot those points, 2, 0, 2, 1, 2, 2, 2, negative, you'll quickly see that it's vertical. Okay? All right, so, by deduction, you could say, all right, if x equals 2 is a vertical line, then y equals 2 is probably a horizontal line through 2, and that would be right. Okay, let's try the next one. Well, actually, I was thinking to spice this up a little bit. Once you discover Wolfram alpha, it kind of becomes your new best friend. So just for grins and giggles, let's tell Wolfram alpha to do that. So let's tell it to graph 4 minus x equals 2 and see what it says. It's a nice little toy. Hit enter. So it's thinking. Notice it likes the command plot. Now, the odd thing, this is very odd, and this would be confusing to a student too. You say, well, what in the world did it plot? Well, it looks like it plotted a horizontal line, here in, this is where you have to be very careful of Wolfram alpha. It looks like it plotted a horizontal line through 2, but what it really did was it flipped the axes. So that's kind of a good, beware. You have to be very aware of Wolfram alpha because sometimes for some odd reason it flips the axes. You have to command it in a certain way to get it to not do that. Now I'll show you some tricks of the trade. This is just what I mean by getting used to Wolfram alpha. If I type it in, exactly how it looked in its original form, which was 4 minus x equals 2, it produced something that didn't look right? So I got x by itself, like we did, when we did it by hand. Because, again, remember the original was 4 minus x equals 2, but then I said to get x by itself, right? So we did that, and we got negative x equals -2, and then we eventually got x equals 2, right? So notice the command. If I just tell it plot x equals 2 on certain bounds, now I even told it what bounds to put on there. If I take away those bounds, let me just do that. Even if I take away those bounds, and just say plain old plot x equals 2, it should still realize that I want a vertical line. Let's try it. See, it's thinking. And boom, it does it. Yep. So long story short, isolate your variable. See, it's given us the vertical line, which we knew it was going to be. So the big thing about Wolfram Alpha, I can say, is be very careful of the commands, right? Okay, let's try the next one. So like I say, you might be tempted to do this next one with Wolfram Alpha now, but like I said, that's just a crutch. Make sure you can do it by hand first. So in this next one, I'm just going to rewrite it. It's 3x minus 12y equals 0, and they want us to find the x and y intercepts and graph the equation. Well, now you know, hey, if I got to find the x and y intercepts, I got to make that little mini table, right, with zeros. So put 0 in for x, and what you're going to get out for y, well, you get out 0. But the problem is, if you put 0 in for y, what would x have to be? Well, it'd also have to be 0, and then you say, uh-oh, I only found one point. It says find the x and y intercepts. Well, they're the same point, their origin. So if I zoom in here, this graph is definitely running through origin, okay? But that doesn't help me graph the equation. So then I always say, all right, if you only found one point that lives, you need 2 points to determine a line, right? So just pick another pretty x, say 4. Well, why is that pretty? If I store it in for x, I'm going to get some good output. Meaning what? 3 times 4 minus 12 times y equals 0, right? 3 times 4 is 12. So 12 minus 12 times what equals 0? Well, what would y have to be in order for that to be true, right? Y would have to be 1. How come? Because 12 times 1, makes 12, and 12 minus 12 is 0. So you're probably figuring on y being 1. Well, now let's go ahead and plot those points. 4, 1, that's a pretty point. So over 4, up 1, right about there. And you had your other point right there at origin. So now we can just go ahead and connect the dots. Now, like I said, my little line's a little thick for that grid. But now for grins and giggles, if you like, you can check that on Wolfram Alpha. But for time's sake, let's go on to the next one. Okay, in this next problem, number 17, we're told to calculate the distance, 17 here, the distance and the midpoint between those 2 points. So, long story short, you have to retrieve from your memory, hopefully, the formulas for distance and midpoint. So the first thing I'm going to do is I'm going to come over here and say, do I have those formulas? Oops, let me hit pause. Okay, so the first thing I'm going to do is say, gee, do we have those formulas memorized? So for starters, we just want to recite the distance formula, which is big square root x2 minus x1 whole thing squared plus y2 minus y1 whole thing squared, all under a big square root. Okay, and midpoint, which is a coordinate, and again, this technically should have been learned in the level before, but it's good to recap. x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. That's going to get you the coordinates of your midpoint. So, for starters, let's try 17. So I'm actually going to, you have the formulas there, I have them in my head. So I'm going to erase them now and then rewrite those points. Okay, so let's let this be your x1, y1, and let's let this be your x2, y2, and let's start plugging and chugging. So when you're doing distance, big square root, x2 minus x1, be very careful of the signs, whole thing squared, plus, I'm going to scoot this over here, plus y2 minus y1, so 9 minus minus 9, whole thing squared. And really you just have to promise yourself that you're not going to make a sign error, which is tough. So this becomes plus 1 here, so negative 9 plus 1 is negative 8, and then you square it, you got 64. So just be super careful of the signs. Plus, and here 9 minus minus 9 is really 9 plus 9, which is 18. And then you take 18 and square it, well, you got a big number, right? 324. All right? But now 324 plus 64 is something, 388, right? So basically, long story short, we'll be arriving at the square root of 388. Now if you go over here and look at your answers, you say, none of those answers say the square root of 388. So you got a couple options. You could look at the decimal equivalent of root 388. So the square root of 388 is like about 19.7. And then what you could do is you could look at, say, 2 root 97. So hit 2 square root 97 on your calculator, and aha, I see it's the same decimal equivalent. So that's one way of doing that. If you don't feel like breaking down the radical, we're going to talk about breaking down the radical later. But for now, you can see that 2 root 97 is the same decimal equivalent. But the thing is, this answer over here, this is the calculation for the midpoint, and we haven't verified that that indeed is the midpoint yet. So let's take a look. Okay, so as we begin plugging and chugging into midpoint formula, x1 plus x2, so -1 plus -9 divided by 2, comma, and then y1 plus y2. So -9 plus 9 divided by 2. And then, that's a coordinate. So let me scoot that over. So you do have to remind yourself, note to self, that that's a coordinate. All right, well, -1 plus -9 is -10 divided by 2 is -5. So -5 comma something. Well, -9 plus 9 is 0. 0 divided by 2 is 0. Aha. So we see that the midpoint is at -5, 0, which we were tending towards this answer anyway. So looks good. Now the other one, number 18, you're doing the same maneuvers. You're doing the plug and chug with the distance and the midpoint formula, except it's abstract because there's x's in there. So I'm going to let you play with that one on your own. For time's sake, I want to start to talk about the center and the radius of a circle. Okay, so in order for us to do these last few problems, we have to remind ourselves a little bit about standard form of a circle. So I'm just going to say circle reminders here. Recall that x minus h whole thing squared plus y minus k whole thing squared equals r squared is standard form of a circle. And what does that mean? That means that by inspection you can look at it and know that hk is the center and that r is the radius of your circle. Okay, well, what does that mean? Well, let's take a look. I'm going to erase this here, but I'm going to put a little light example before we do the worksheet. Okay, example. Suppose you had x minus 2 whole thing squared plus y minus 4 whole thing squared equals 25. What could you tell me? Well, you could tell me that that equation is in standard form, meaning look at the format. It matches up totally with this, right? You can look at it and by inspection identify the h and the k. Okay? So if you can do that, that's what you do for starters. You just by inspection state the h and the k. So h comma k, well, we can see that that would be 2 comma 4. So then what is 2 comma 4? Well, that's my center. So that would be the center of the circle. And then, r squared is 25. So if r squared is 25, r is 5. So then, in addition to that, we could say the radius is 5. So if r squared is 25, the radius of your circle is 5. So what you're dealing with then, sort of visually, is you're dealing with a circle that has a center at 2, 4, over 2, 1, 2, just sketching, 3, 4. So a center at 2, 4, and a radius that's going to emanate out, 5 units in every direction, from that center. That's the gist. I'm just giving you a light idea. Okay. Main thing is if your equation is in HK form, this standard form here, you'll be able to spot the center and the radius very easily. So speaking of that, all right, let's, for starters, let's look at number 19. It says write the standard equation for the circle. And this time they're kind of reversing the flow, and they're giving us the center and they're giving us the radius. So long story short, what they're giving us is the h and the k. So remember that when they give you that center, boy, that's your h and your k. Okay, so 5, -9. That's my h and my k. So if I simply just plug, and let me erase all this. So if I know my h is 5 and my -9 is k, then I can do x minus 5 whole thing squared plus y minus 9, now, which you really know means y plus 9, but we'll hold that thought, whole thing squared equals, and then they're telling us that the radius here is the square root of 3. So I'm just going to write, oops, I have a whole bunch of stuff from before there. Let me erase that. Okay, so equals square root of 3 whole thing squared. But then you've got to clean that up. So that's x minus 5 whole thing squared plus y plus 9 whole thing, because the negation of -9 is +9 squared, equals 3. Aha! I arrive here. There's my circle. So which answer does that look like? Aha! It's looking like A. Okay? And likewise, you would do the same with number 20. You guys have the answer key attached, so I'm sure you'll be able to figure that out. You just have to remind yourself that origin, it's passing through origin, which is 0, 0. So you might have to think about, and you know the center, 19.6. So by deduction, let me see if I can pull this completely up. Here's where it gets tricky. Process of elimination here. The center is at 19.6, so that's your h and that's your k. So by deduction, you know it can't be this one. It can't be this one. So it's down between, choice C or choice B. And like I said, my tests aren't multiple choice, so you'd have to go through this mechanically. Your h and your k are in play. You just really have to figure out your radius. And here's my hint. I'm not going to full-blown do it for you, but it's passing, it says through origin. Well, origin's at 0, 0. So if you're passing through origin and you've got a center over at 19.6, so you're way over at 19 and up at 6 somewhere in space, the main idea is, even if you draw this, what you're doing is you're swiping out a circle, with a certain radius. But the question is, what is the length of that radius? So my big hint is you're going to have to retrieve your distance formula and get the distance, from origin to that point, 19.6. So long story short, plug and chug into the distance formula and get the distance between those 2 points, origin and 19.6, and you'll have your radius, and then you can take it from there. Okay, just want to do this last one with you, which is number 21. Last one, I promise. Okay, so at this moment, number 21, it says find the center and the radius, but it's like the equation's awkward, right? It's not molded into the right form. So, basically, in the end, I want, x minus h whole thing squared plus y minus k whole thing squared equals r squared. So you basically want your constant, and by the way, your constant there is 1. So it's basically like, let's take all this x stuff and move it to the other side of the equation. So if I can write that out, let me write out the original here. So if you have y squared equals 1 minus, x plus 4 whole thing squared, why don't we just add this quantity of x plus 4 whole thing squared to the other side? And what would we get? Well, we'd get it in a prettier form, right? So then we'd end up with x plus 4 whole thing squared. I'm going to erase this because I'm going to just kind of do that mentally. So we basically end up with x plus 4 whole thing squared plus y squared equals 1. Aha! Now by inspection we can look and we can identify the h and the k. Well, it says x plus 4, and it's supposed to say x minus an arbitrary constant. Well, x minus minus 4, so long story short, your h is actually -4. And your k is 0. How come? Because it doesn't say y minus something. It's like invisible zero. It's kind of like saying y minus 0, whole thing squared, equals 1, right? So you know your k is 0. So now we can kind of look, and we could say, all right, if h is -4 and k is 0, -4, 0 is my center. So far it's looking like answer A. And yeah, here, 1, if r squared equals 1, then you know r equals 1. So your radius is 1 as well. So that's why the answer is A. Okay, so oftentimes you have to take your equation and mold it into HK form so you can identify the center and the radius. All right, hope that helps. Good luck.